Section 8.6 is on natural logarithms, which is very similar to the logarithms that you had been doing before. Starting off, we have to talk about the concept of an inverse. It's kind of like an opposite function. Okay, so the exponential function y equals e to the x has an inverse, which is the log with a base of e of y equals x. Okay, so you can see if we would do the loop like we've done before, you start at the e, raise it to the x power equals y. So you have e to the x equals y. That's the kind of the inverse of that exponential function. Okay, well, due to how often we use the natural logarithm, which is what that function is, we will often rewrite it as ln, or log natural, of x. Okay, so that right there is the same thing as this, but since we use it so commonly, we write it with an ln instead of log base e of x. Okay, because of that, all the exponential rules that we had talked about before will still work out the same way. So starting off, what we have right here, 2 ln of 12 minus ln of 9. Hopefully you remember from before, subtraction between two logarithms turns into division. Okay, also, any number that's in front of a logarithm, like that 2, can come up as an exponent of that logarithm. Okay, so what we're going to do is rewrite it, one natural logarithm. On the top, we have 12 squared, and because of this minus, anything that's being subtracted will get divided on the bottom. So it's natural log of 12 squared divided by 9. Now it's possible we could reduce that more, but for now, I'm fine if that's what you come up with. Okay, your next one, this 4, goes up to the x, this 3 goes up to the y, and this plus that's in between the two turns into multiplication. So that's the natural log, x to the 4th, y cubed. Okay, for the u try, same idea as well. The 2 goes up to the 6, so it's the natural log of 6 squared times 2. Like I said, you could do 6 squared times 2 and get ln of 72. But again, I'm more focused on you learning the rules for now. Okay, the 3 goes up to the y, so we have the ln of x divided by y cubed. Okay, this next section, some of it you can do just via calculator work. So let me point out where some of this is. The natural logarithm is on the left side of your calculator, right here ln, and so this first one, the ln of 1, is 0. Okay, now add the note. Any log of 1 is 0. Because any number raised to the 0 power is 1, always. Anything raised to the 0 power is 1. And since a log is just an exponent, anytime you have the log of 1, that's saying what number or any number raised to what power would be equal to 1. And it's always the 0 power. Okay, now this one. E raised to the ln of 3. Anytime you see the same base as the base of the log, it cancels out, and so we just have 3. Same thing here. This 2 can come down. So we have 2 ln e over 2. The 2's cancel out. Anytime the base of the log is the same thing as what you're taking the log of, that just becomes 1. Okay, so by the same rationale, this e and the base of that log are the same, so they cancel out, just leaving us with 12. Okay, ln of e cancels out, just leaving us 5. And on the top of the next page, this 15 comes down. 15 ln of e over 3. ln of e is 1. 15 over 3 is 5. Okay, the next type of logarithm. Type of equation, solving it. Okay, this is when you have the log on one side only. Okay, so the first thing you need to do is make sure the log is by itself, completely combined together, which it is. Okay, the next thing you want to do is the circle method. So start at the base and then exponentiate it. Do the circle, so e raised to the 6th power. That is equal to this stuff in here, 2x minus 4. Okay, well, this you could find out in your calculator. The e button is either above the divided by, or it's above the ln. Okay, so we can do second ln. to the 6th power, hit enter, and we get 403.4. Okay, now it's a simple linear equation where you have to add 4 to both sides. So we get 2x equals 407.4, and then divide by 2. And so we get x equals 203.7. Okay, it's the same thing for number 2, except the only difference is we don't have this ln by itself yet. Okay, so what we can do is combine both the logs that are on this side. This minus turns it into a division, so it's ln x plus 2 over 4 equals 3. Okay, now loop it out. E to the 3rd power equals x plus 2 over 4. Okay, you can multiply both sides by 4 to get rid of the 4 from the denominator. So x plus 2 equals 4e cubed, and subtract 2 from both sides. X equals 4e cubed minus 2, and all of that you can type in 4e cubed minus 2. 78.3. Okay, both of these u-tries would work out the same way. I'm going to take you up to the step where we have the log by itself, then I'll let you solve the rest on your own. Okay, this ln needs to be by itself. So we need to get rid of that 7 over 7 over 7. So really what we have is ln of 2x plus 5 equals 8/7, which you can divide out, get the decimal if you want. Okay, next step would be e and do all that. Okay, your next one, again, we want this ln by itself. There's no other ln to combine it with. Okay, so first thing, subtract 3 from both sides. You get negative 4 ln 8x plus 1 equals 9. And then divide both sides by negative 4. So ln 8x plus 1 equals negative 9 over 4. And then you would do e to all that equals that. Okay, your next type is solving natural logarithm equations when you have an e on one side and then also the x is up in the exponent. Okay, so this is a large reason of how logs can be useful for us. The first thing, get e to the whatever by itself. Okay, that means adding 8 to both sides here. E to the x over 2 equals 14. Okay, and then after that, do the natural log of both sides. So one nice thing about the logarithm is it allows us to move exponents down. So what we're going to do, ln of e equals ln of 14. Okay, having that, we can move x over 2 down. Ln of e equals ln of 14. Well, from the previous page, hopefully you remember that ln of e is just 1. So we have x over 2 equals ln of 14. Well, multiply both sides by 2. We get x equals 2 times ln 14. And you can plug that into your calculator to get the decimal. The next page, same idea. Okay, so subtract 6 from both sides first. We're trying to get this e to the 3x by itself, even getting rid of that 4 that's in front. So that first step is going to give us 4e to the 3x equals 8. Divide both sides by 4. We get e to the 3x equals 2. Okay, and at this point, the natural log of both sides. This exponent 3x can come down in front. So we have 3x times the natural log of e equals the natural log of 2. Okay, the natural log of e is 1, so we can cancel it out, and we can divide both sides by 3. So we get x equals the natural log of 2 over 3. And again, you can plug that into parentheses. Make sure this closing parentheses is on it first before you divide by 3. Okay, the u-tries work out the same way. Okay, so this word problem works out pretty similarly. An initial investment of $200 is now valued at $254.25. The interest rate is 6%. Compounded continuously. Okay, so hopefully you picked up the compounded continuously formula is this. The final amount is equal to the principal times e raised to the rate times time. Okay, how long has the money been invested? So we're trying to solve for this t value. Okay, and so e to the r and p and a, we should have values for all those. Okay, well, the final amount that they had was $254.25. That's equal to the initial amount of $200 times e. So e is just that number on your calculator. It's roughly 2.78128 or 2.81, something like that. Okay, and the rate is 0.06. The time is t. Okay, well, we want, just like we wanted before, we want this by itself, and we're going to take a log after we get it by itself. Okay, so first step, dividing by 200 on both sides. Okay, so on that left side, you want to go ahead and divide that out. Since it's already a decimal, there's no point in trying to keep it in a fraction. Sometimes if they've been exact integers, you don't want to switch it to a decimal too early. Okay, but this one, keep as many decimals as you can. I'm going to keep them all 1.27125. Okay, and that's equal to e raised to the 0.06 times t. Okay, ln, and we're going to move this down in front. And remember, the ln of e is going to cancel out. So I'll still write out that next step. So the ln of 1.27125 equals 0.06t and then ln of e. Okay, ln of e is 1, and so just divide both sides by 0.06. Okay, and let me show you how you need to do this. Make sure, again, I'm trying to really emphasize, close the parentheses before you divide by that 0.06. This is the ln of 1.27125 divided by 0.06. 4.0000. Great. So t equals 4.00 years. That means in order for the money, when you put it in the bank, to go from $200 to $254 at a 6% interest rate compounded continuously, it would take 4 years. Okay? Now, the homework from class was actually on the last page, kind of expanding, condensing, and solving each of these equations. Okay, so I recommend you do that. You can check the notes online for some of the answers.